Hey folks, just wanted to revisit that opening example. So the salmon, we have the mean of 20, the standard deviation of 4. Okay, so now this is if I'm just looking at one salmon. So let's see what it means to talk about the mean of the X bars. So I introduced that idea, but let's do an example. So here's the idea. Let's say sample size is 16. That's a lot of salmon. 16 of them is kind of a lot. So you reach in, randomly grab 16 salmons and figure out the average length, the X bar, of that group of 16 salmons. It's probably going to be really, really close to 20. Okay, so it's probably like 21 or something. So there's an X bar. Okay, let's do it again. Reach into oceans, lakes, streams, pull out 16 salmons, get the average length of that group of 16, and it's probably, again, really close to 20. So you keep doing this all day long, and you'll notice that these X bars keep clustering really, really close to 20. Every once in a while, you'll get a group of really small salmons, very rarely. Every once in a while, you'll get a group of really large salmons, very rarely. But you'll notice what's happening is that the bell curve, it's going to be centered around 20, just like our original situation. But notice that the bell curve is going to get all squishy because everything's clustering around 20. You'll notice that the standard deviation has changed. It's gotten all squished together. So our new standard deviation, the standard deviation of our X bars, is just sigma over root n. So our new standard deviation, our, what did we call it earlier? Standard error of the mean, is just going to be sigma, we said, is 4, over the square root of sample size, which was 16. So that's going to give us 4 over 4, which is 1. So you see how everything is basically between 19 and 21. So if I'm looking at a sample size of 16, the X bar from that sample size is usually going to be between 19 and 21. It's going to be within 1 of that center. Okay, I hope that made sense. Let's do the worksheet now.